Hey everyone, welcome back to DSP Lectures. In this video, we are going to solve some questions based on the topics we have studied so far. We will see 3 questions in total. The first question is based on operation of sequences, and second and third questions are based on the block diagram representation of discrete time systems. So let's start our lecture. The first question is, consider the following 7-length sequences defined for n in the range -3 to +3. The sequences are x of n, y of n and w of n, and each of these sequences have a length of 7 ranging from n equal to -3 to n equal to +3. The samples corresponding to n equal to 0 are these. Now we need to generate the following sequences: u of n, v of n, s of n and r of n. For those who are unfamiliar with the theory on operation of sequences, please refer to lecture 3 of our lecture series. The link to this video is available in the description below. Okay, so we have u of n equal to x of n plus y of n, which is 3 plus 0, which is 3, minus 2 plus 7, which is 5, 0 plus 1, which is 1, 1 plus minus 3, which is minus 2, 4 plus 4, which is 8, 5 plus 9, which is 14, and finally 2 plus minus 2, which is 0. So this is our sequence u of n. Next we have v of n equal to x of n into w of n, which is equal to 3 into minus 5, which is minus 15, minus 2 into 4, which is minus 8, 0 into 3, which is 0, 1 into 6, which is 6, 4 into minus 5, which is minus 20, 5 into 0, which is 0, and finally 2 into 1, which is 2. So this is our sequence v of n. Now coming to the next subsection, we have s of n equal to y of n minus w of n, which is equal to 0 minus minus 5, which is plus 5, 7 minus 4, which is 3, 1 minus 3, which is minus 2, minus 3 minus 6, which is minus 9, 4 minus minus 5, which is plus 9, 9 minus 0, which is 9, and finally minus 2 minus 1, which is minus 3. Thus we obtained our sequence s of n. Now lastly we have r of n equal to 4.5 times y of n, which is equal to 4.5 into 0, which is 0, 4.5 into 7, which is 31.5, 4.5 into 1, which is 4.5, 4.5 into minus 3, which is minus 13.5, 4.5 into 4, which is 18, 4.5 into 9, which is 40.5, and finally 4.5 into minus 2, which is minus 9. So this is our sequence r of n. Thus we have found out the sequences u of n, v of n, s of n and r of n. That completes our first question. Coming to the second question, we need to analyze the block diagram given in figure and develop a relationship between x of n and y of n. For those who are unfamiliar with this topic, the theory for this question is covered in lecture 3 of our DSP lecture series. Okay, now to answer this question, let us assume that the signal here is v of n. So the signal here will be v of n minus 1, as this is a unit delay. Now here we have a multiplier with scalar beta, so the signal here will be beta times v of n minus 1, right? Now this signal extend all the way here, so the signal here is also v of n minus 1. Therefore the signal here will be alpha times v of n minus 1, and similarly the signal here will be gamma times v of n minus 1. Now at this adder circuit, x of n is added with alpha into v of n minus 1 to get v of n. So the relation is x of n plus alpha into v of n minus 1 equal to v of n. Let us name it as equation number 1. Similarly, at this adder circuit, beta into v of n minus 1 and gamma into v of n minus 1 is added to get y of n. So the relation is beta into v of n minus 1 plus gamma into v of n minus 1 equal to y of n, which is equal to beta plus gamma into v of n minus 1, and let us name it as equation number 2. Okay, so we have two equations containing x of n and y of n. Now we have to manipulate these two equations to obtain them only in terms of x of n and y of n. For that, let us delay the entire equation 1 by 1 unit. That is, in equation 1, we replace n with n minus 1, which gives us x of n minus 1 plus alpha into v of n minus 2 equal to v of n minus 1. Let us name it as equation number 3. Substituting equation 3 in equation 2 gives us equation 3 in equation 2 gives us y of n equal to beta plus gamma into x of n minus 1 plus alpha into v of n minus 2. Expanding the brackets, we have beta plus gamma into x of n minus 1 plus alpha into beta plus gamma into v of n minus 2, and let us name it as equation number 4. Now we need to eliminate this v of n minus 2 out of this equation. For that, let us delay equation 2 by 1 unit. So replacing n in equation 2 with n minus 1, we have y of n minus 1 equal to beta plus gamma into v of n minus 2, which gives us v of n minus 2 equal to y of n minus 1 by beta plus gamma. Let us name it as equation number 5. Substituting equation 5 in equation 4 gives us 5 in 4 gives us y of n equal to beta plus gamma into x of n minus 1 plus alpha into beta plus gamma into y of n minus 1 by beta plus gamma. So this beta plus gammas cancel out, giving us y of n equal to beta plus gamma into x of n minus 1 plus alpha into y of n minus 1. So this is the relation between x of n and y of n in this particular question. Now let us move to the third question. Here also we need to analyze the block diagram in figure and develop a relationship between x of n and y of n. Let us start by marking the signals at each point. This is a unit delay operator whose input is x of n. So the output will be x of n minus 1. Again we have a unit delay operator, so the output here will be x of n minus 2. Now this is a multiplier with scalar gamma, so the output here will be gamma times x of n minus 2. Now the input to this unit delay operator is x of n minus 2, so the output here will be x of n minus 3, which is fed to this unit delay operator. Therefore we get the output as x of n minus 4. Coming to this adder circuit, it has x of n and x of n minus 4 as the inputs. So the output will be x of n plus x of n minus 4. And this is passed on to a multiplier with scalar alpha. So the output here will be alpha times x of n plus x of n minus 4. Now in similar fashion, the output of this adder circuit will be x of n minus 1 plus x of n minus 3, and this is passed on to a multiplier with scalar beta. So the output here is beta times x of n minus 1 plus x of n minus 3. Again we have adder circuit here, so the output here will be alpha times x of n plus x of n minus 4 plus beta times x of n minus 1 plus x of n minus 3. Now the input to this adder circuit is gamma times x of n minus 2 and this expression. So the output y of n will be y of n equal to alpha times x of n plus x of n minus 4 plus beta times x of n minus 1 plus x of n minus 3 plus gamma times x of n minus 2. So this is the relationship between x and y in this particular question. Okay, so that's all for this lecture. I hope that all the concepts that were taught in this video are clear to all of you. If you have any doubts, feel free to ask them in the comments. Either we or some other viewer will surely help you out. If you found this lecture useful, please like the video and support us by subscribing to the channel. In the next video, we will be seeing more solved examples. Thank you for watching Topperly and have a great day.